Welcome! In this video, we shall follow up on the second fact we discussed in the previous video. When we reach the final tableau of the original problem and the dual problem, then the values for y1 up to ym, for which this minimum is obtained in the dual problem, are the coefficients in row 0 corresponding to the slack variables in the original problem. That is, the value of yi is the coefficient for si. Are there any meanings for these values obtained? In this video, we shall answer this question. Let's refer to the following example. Please make a pause here, read the question, and write down the linear programming problem in standard form and its corresponding dual problem. Let x1 denote the number of units of soap A produced and x2 denote the number of units of soap B produced. Then the company's revenue is given by this function expression 5x1 plus xx2. We want to maximize the company's revenue subject to constraints, according to the information given from the question about the labor resources, on the amount of time spent on producing the soaps, and the amount of oil, which is the raw materials for the soaps. So the first constraint on the labor working time is 3x1 plus 2x2 less than or equals to 120, and the second inequality represents the constraints on the amount of oil, which is 2x1 plus 3x2 less than or equals to 130. Consider this as a linear programming problem. This problem is to maximize z equals to 5x1 plus 6x2 subject to these constraints, where x1 and x2 are non-negative. If we consider the dual problem of this original problem, we will formulate the dual problem as to minimize z equals to 120y1 plus 130y2 subject to these new constraints where y1 and y2 are non-negative. Although in the original problem we need to maximize z, whereas in the dual problem we need to minimize the z, but we notice that when both of these problems reach the optimal solution, the two values for z will be the same. And this z represents the maximum value of the company's revenue that can obtain. We have already solved these two problems in the previous video. The following are the solutions we obtained after solving the original problem and the dual problem. For the original problem, we obtained that z has a maximum value of 220 when taking x1 equals to 20 and x2 equals to 30. Therefore, it means that the company's revenue is maximized at 280 euro if 20 units of soap A and 30 units of soap B are produced. For the dual problem, we obtain that z has a minimum value of 280 when taking y1 equals to 3 over 5 and y2 equals to 8 over 5. But since we know that the minimum value of z, which is 280 in this dual problem, is always the same as the optimum value of z achieved in the original problem. Therefore, this value 280 still represents the company's revenue is maximized at 280 euro. Now, what does the value of y1 and y2 obtained in the dual problem represent? Now we have a question. What do the value of y1 and y2, which we obtained from the final solutions of the dual problem, represent? Before answering this question, let's refer to other questions. In real-life situation, the owner of the company would wish to know more information. For example, the owner wished to know if the company have the same amount of oil, that is 130 liters, And if they hire a labor to work for 1 more minute on top of these 120 minutes, will there be increase in the revenue? How much is this owner willing to pay for these extra minutes of labor work? Besides, the owner wishes to know if the company have the same number of minutes of labor work, that is 120 minutes, and if the owner buy 1 more liter of oil in addition to these 130 liters, will there be increase in revenue? And how much is this owner willing to pay to buy this extra liter of oil? Let us explore the owner's first question. That is, the owner wishes to know if the company have the same amount of oil, that is 130 liters, and if the owner hires a labor to work for 1 more minute in addition to this 120 minutes, will there be increase in the revenue? How much is the owner willing to pay for these extra minutes of labor work? So instead of having 120 minutes for the total time for the labor, it is now increased to 121 minutes. We shall solve this linear programming problem again with a new constraint to the first inequality. Therefore, the original problem and the dual problem will be changed correspondingly. Let's suppose we solve the original problem by the simplex method. Please refer to the following deductions by yourself. We finally obtain the final tableau of the original problem as follows, and we notice that the solution is optimal as long as we take x1 equals to 20.6 instead of 20 before, and to take x2 equals to 29.6 instead of 30 before. s1 and s2 are equal to 0, and the corresponding value for z will become 280 plus 3 over 5, which is 280.6. It means that z has a maximum value of 280.6, which is achieved by taking x1 equals to 20.6 and x2 equals to 29.6. It means that if 1 more minute of labor is hired, then the company's revenue becomes 280.6 instead of 280. And it means that if 1 more minute of labor is hired on top of 120 minutes of labor time and 130 liters of oil, then the company's revenue increases by 0.8 euro. In other words, if the cost of hiring a labor to work for 1 more minute is more than 0.6 euro, then the company will not get more profit. It means that when the company is having 120 minutes of labor time and 130 liters of oil, the company is willing to bear the cost of hiring the labor for 1 more minute if this cost of hiring the labor for 1 more minute is less than or equal to 0.6 euro. Let us explore the owner's second question. That is, we wish to know if the company have the same amount of minutes of labor work, that is 120 minutes, and if the owner buy 1 more liter of oil in addition to the 130 liters, will there be increase in the revenue? How much is the owner willing to pay to buy this extra liter of oil? The right-hand side value of the second constraint inequality of the original problem will change from 130 to 131. Therefore, the original problem and the corresponding dual problem will change the formulation correspondingly. We are going to solve the original problem by the simplex method. Please refer to the following deductions by yourself. Then, at this stage, the solution reached the optimal, and this is the final tableau of the original linear programming problem because there is no longer negative coefficients for those variables in row 0. Therefore, this solution is optimal when we take x1 equals to 19.6, x2 equals to 30.6, s1, s2 equals to 0, and the corresponding value for Z is 281.6. It means that Z has a maximum of 281.6, which is achieved when taking these two values for x1 and x2. And it means that when the company buys 1 more liter of oil for the production, its revenue is now increased from 280 to 281.6. This means the company has an increase of the revenue with the amount 1.6 euro. In other words, if the cost of buying 1 liter of oil is more than 1.6 euro, then the company will not get more profits. It means that when the company has 120 minutes of labor time and 130 liters of oil, the company is willing to bear a cost of 1 liter of oil as long as this cost is less than or equal to 1.6 euro. Let us return back to our previous question. For the solution in the dual problem, we get y1 equals to 3 over 5 and y2 equals to 8 over 5. What do these two values represent? It turns out that the value of y1 and y2 obtained in the dual problem give us the information related to the owner's two questions. Refer to our situation, the first inequality in the original linear programming problem represents the constraints on the labor working time. In the dual problem, we get y1 equals to 3 over 5, which is 0.6. This value 0.6 measures the maximum price the company is willing to pay to 1 additional minute of the labor. In our situation, the second inequality in the original problem represents the constraints on the amount of oil. Then, in the dual problem, the solution y2 equals to 8 over 5, this value 1 over 6, measures the maximum price the company is willing to pay to buy 1 more liters of oil. In conclusion, the variables y1 and y2 in the dual problem measure the marginal values of labor and oil in this example. This measures the maximum price the company is willing to pay to 1 additional unit of resource. It is also sometimes referred to as the shadow price. So in our situation, the company is having 120 minutes of labor time and 130 liters of oil. The company is willing to pay up to 3 over 5 euro, that is 0.6 euro, for 1 additional minute of labor, and 8 over 5 euro, that is 1.6 euro, for 1 additional liter of oil.